and welcome to the Learning Enhancement session on naming compounds and Key Stage 4 chemistry. Before we get started, can you please make sure you have a pen, a pencil, a ruler, a highlighter or another coloured pencil, and your journal or your printed periodic table. Okay, can you also make sure you're in a quiet room, no distractions, no technology to distract you otherwise. Okay, can you just pause the video just for 10 seconds and write down the learning objective to understand how to name compounds. Okay, so I've got the retrieval practice here. Can you, in your margins, write down 1 to 5 and answer the 5 questions on here. Give yourself 5 minutes. So pause the video for 5 minutes and then we'll go through the answers. So 5 minutes, go. Now, your 5 minutes is up there. Can you pick up another coloured pen or pencil, green pen preferably, and we'll go through these and mark them. Okay, so question 1 simply asks, what does the mass number represent? Now this is on the periodic table. Above every element you'll have 2 numbers, one being the mass number, one being the atomic number. So the mass number is a number of protons and neutrons inside the atom. So the number of protons that's contained inside the nucleus of the atom. So the number of protons and neutrons. Number 2, what does the atomic number represent? The number of protons or the number of electrons in the atom. Okay. Number 3, how many neutrons does oxygen have? So it has 16 as the mass number, 8 as the atomic number, and that means it has 8 neutrons because you just do 16 take away 8. Number 4, what mass does an electron have? So its mass is 0.005 or negligible. That means it's very, very small, so almost nothing. It's there, but it's very, very small. And what mass does a neutron have? Simply put, just 1. Just 1. So give yourself a mark out of 5. You've got 5, excellent. 4, well done. 3, good. 2 and 1, need to improve on that. Don't worry about that though. Okay. So what this learning session is about is we're going to write word and symbol equations and then balance a couple symbol equations at the end. So that's what today is about. So just for a starter, the chemical name for water is H2O. Pause the video just for a minute. And what do you think that means, H2O? And then can you think of any other chemical names? So pause the video just for 2 minutes. Go. Okay, so hopefully you've had a little think there about what H2O stands for. So obviously, H2O water, it contains 2 hydrogen atoms, H2 there, and 1 oxygen atom, and this of course is a compound. Can you think of any other chemical names? So a few I came up with, so you can jot these down if you haven't already. CO2, which is carbon dioxide, NaCl, that's your salt that you put in your fish and chips, and then H2SO4 is sulfuric acid. So those are just a couple of examples. I'm sure you've got a few more yourself. They are just simply the chemical names for these compounds. And the example here, so CO2 has 1 carbon, 2 oxygens, Na is just 1, and Cl is just 1 also, and H2 there's 2 hydrogens, 1 sulfur, and then 4 oxygens. If there are a small number after a single letter or element, that means it's 2 of those atoms there, 2 oxygen atoms, and when compared there's no number, that means it's just 1 of itself. Okay. So what do you notice about the elements and the compounds names? Well, if you look at this, the elements and put together and were chemically reacted to make a compound, the only difference you see on here is it goes from chlorine to chloride. So when it's gone element, it's chlorine, but when it becomes a compound, it becomes a chloride. So sodium and chlorine makes sodium chloride. Lithium plus bromine makes lithium bromide. Okay. So I want you just to pause the video for a second and just read the following question. And then can you answer the question, what name would we give to iron and sulfur? So if you react them together, what would the name be? So pause the video just for 30 seconds and write out the word equation only. Okay, so 30 seconds is over there. What name would you give to iron and sulfur? If you react them together, it would be iron sulfide. So iron plus sulfur makes iron sulfide. You notice it changes from sulfur to sulfide, just like the previous one. with the example there, following there, so sodium plus chlorine makes sodium chloride. Okay, can you pause the video again for 2 minutes and do the same again? Read the top paragraph and then answer the second bullet point question. So give yourself 2 minutes, go. Okay, hopefully you've done that. So if we react calcium plus carbon plus oxygen, what would you get? Well, hopefully you got the answer calcium carbonate. So calcium plus carbon plus oxygen makes calcium carbonate. 8, if the second word of the compound has 8 in it, that means it contains oxygen. If it's ide, it means it doesn't. If it's got 8 in it, it contains oxygen. Okay, so just going to explain the next task here. When we burn anything, the material you're burning reacts with the oxygen in the air. So there's oxygen around it, that's the fuel that's using it, and it combines with it. So if you burn magnesium, it reacts with the oxygen in the air to form magnesium oxide. So, following the same questions from earlier, on the next slide, for each metal, write the full word equation. So, what I want to do, going to give you 7 minutes for this. 7 minutes. Can you copy and complete these full word equations? So for number 1, magnesium plus oxygen, what does it make? And so forth. Fill in the blanks. I'll give you 7 minutes for that. Go. Pens down. Can you now pick up your green pen or another coloured pen, pencil, and we're going to go through these and give ourselves a mark out of 8. Okay, so on the next slide are the answers. So here, so magnesium plus oxygen, that makes obviously magnesium oxide. I did mention that previously. Question 2, sodium plus chlorine makes sodium chloride. That's also on previously. Lithium plus bromine makes lithium bromide as well. Calcium plus chlorine makes calcium chloride. Number 5, sodium plus hydrogen plus oxygen makes sodium hydroxide. Bit of a trick question there, that can make hydroxide. Copper plus sulfur plus oxygen makes copper sulfate. Remember the 8, so it shows that it's not sulfoxide or anything like that, it's sulfate. Calcium plus carbon plus oxygen makes calcium carbonate for number 7. And then the last one for number 8, sodium plus nitrogen plus oxygen makes sodium nitrate. Once again, it mentions the 8. Okay, so give yourselves a mark out of 8 there. If you got 6 and above, excellent, well done, good understanding. 5 and below, need to improve in that in the next part. Okay, so following the same trend as earlier, can you pause the video just for 2 minutes? Can you read the 2 paragraphs below and write the full word equations for these 2 scenarios? This is a common GCSE exam question. The word equation will need to be extracted from the information here. So pause the video to 2 minutes and write in the 2 full word equations, please. We'll start off with the first one here. Can you pick up a green pen or another coloured pen and pencil, and we'll mark these out too. So, lead nitrate reacts with potassium iodide. This produces a yellow solid called lead iodide and a clear liquid called potassium nitrate. So this will obviously make lead nitrate plus potassium iodide, reacting them together to make lead iodide and potassium nitrate. So they have just been swapped over. That's all that's happened here. Been rearranged. In a car, so the second one here, in a car, when the engine is started, enough energy is produced to combine nitrogen from the air with oxygen to form nitrogen dioxide. A bit easier this one, a bit simpler. Simply, nitrogen plus oxygen makes nitrogen dioxide. Just give yourself a mark out of 2 there, guys. Excellent if you've got 2. 1, well done. Okay, so we're going to move on to symbol equations now, guys. So in the same format as the word equations, we use symbol equations as they save time and they allow us to know how much there is of each element. For example, H2O, there's 2 hydrogens and 1 oxygen, as we've already established. So pause the video, 30 seconds, tell me how many of each element are there. So what does CaCO3 tell us? Okay, so CaCO3, which is calcium carbonate, so it's rock and limescale, that limestone, that is found underneath the ground. Calcium carbonate contains, it has 1 calcium, so 1 calcium atom, 1 carbon atom, by the C there, and then 3 oxygen atoms. You can tell it's 3 because it's small 3 after only the oxygen. That's what you can tell us. So, balancing symbol equations. Symbol equations, we need to balance them to show that mass is being conserved. More about that later on in the topic. So, you can never change a formula when balancing an equation. You can only put a number in front of a formula. So let's consider how these 2 molecules of CO2 could be changed. So we can't put C2O because that would change its compound. That wouldn't be carbon dioxide. You can't put CO4 because once again, it changes the number of oxygens and it makes a different compound. Can't be C2O2, once again, changes the number of the different compounds, so it's not CO2 anymore. What we do is put its 2 CO2 in front of it. So that is obviously correct. That's the way to do it. When balancing symbol equations, you put a number in front of the compound itself, compound or the element. Okay. So, no atoms are created and destroyed in a chemical reaction, obviously only rearranged. That is a simple way of describing the conservation of mass. There should be the same number of atoms of each type of element each side of the equation. So for example, if there's 1 magnesium and 2 oxygens, there should still be 1 magnesium and 2 oxygens when you make the product. It should be 3 atoms on each side. It should always be that. It can't create something out of nothing. So, for example, we've got magnesium plus oxygen makes MgO. That is the unbalanced symbol equation. Can you write this down as it is? Pause video for 10 seconds and write that down as it is. So I'm just going to quickly overview how we balance symbol equations just in here. So we've got magnesium plus oxygen and magnesium oxide, just written here. This is unbalanced. How do we know that? Because if we write in the number of atoms there, so we've got 1 magnesium atom there, 2 oxygen atoms indicated by the small 2 there, and then because there's no number here, it's just going to be 1 of each, so 1 magnesium, 1 oxygen. So this is unbalanced, got 3 there and only 2 there. So just indicated by that, so 3 atoms compared to 2 atoms. So how do we change that? Well, we can add a 2 in front of that, times in everything by 2 there, so we're doubling there to make 4, and that makes 4 there. Okay, and then what do you think we're going to put in front of the magnesium? Excellent, that's right, so 2. So 2, add to it, and that will double that to 4 as well, and now it is balanced. This is now a balanced symbol equation. Okay, so can you make sure you've written that down? Pause the video just for 10 seconds just to write that down. Okay, so moving on to the final task, guys. Last task. Can you write down each of the following symbol equations and try and balance them? One of them is already balanced, but you have to find out which one. So pause the video for 5 minutes and have a go. And then we're going to go through it in 5 minutes time. Okay guys, your 5 minutes up there. Thank you for having a go at that. Can you pick up your green pen or an oval coloured pen and pencil? And we're going to go through these nice and quickly so the answers will come up, and give yourself a mark out of 4. Okay, so the first one was already balanced because there's 1 carbon and 2 oxygens indicated there. The second one, you just had to put 2 in front of the H2O and a 2 in front of the H2 to make it 4 hydrogens on each side, and then to counter out the 2 here. This one's tricky question. This is the Haber process, so you to make ammonia. So you had to put 2 in front of nitrogen, 3 in front of the hydrogen, and 2 in front of the ammonia here. And then the last one, guys, you had to put 2 in front of the O2 and 2 in front of the H2O. Give yourself a mark out of 4, guys. If you got 4 out of 4 on that, excellent. That's really well done. It's a higher level skill. That's fantastic. 3, well done. Brilliant. 2, that's fantastic. Well done. Good effort as well. And number 1, and even 1, good effort. Well done. That concludes the video on naming compounds, guys. Have an excellent day. Thank you.